So, good evening, everyone. So, today we are going to discuss the solution for the chemistry portion. So, if we see the first question, they are asking us about the species which is anti-aromatic in nature. So, we all can understand anti-aromatic means it should be have what? 4n pi electrons. As they need to have 4n pi electron, what we are going to see, we have to consider all of the given compounds. Among them, one is there who is having cyclic structure, who is having 4n pi electrons, who is having continuous conjugation. So who is that? This compound, if we see, it has a positive charge over here. Having a positive charge over here, having 2 pi bond, that means that it can undergo not only resonance, it also has 4n pi electrons because 2 pi bond. So 2 pi bond, overall, how many pi electrons? 4n pi electrons. And there is continuous conjugation. So henceforth, what we can consider that this molecule is nothing but what in nature? This molecule is anti-aromatic in nature. Next, question number 2. If you see, they have asked us which one contains only one unpaired electron. So we have to directly go for D and F block. According to the concept of D and F block, we all know that FeCN6, Cn is a strong field ligand. FeCN6 3 minus they have given. FeCN6 3 minus having 3 negative will be giving me Fe3 plus. If I talk of Fe3 plus, Fe3 plus possesses what? Fe3 plus possesses 3d5 electrons. If there are 3d5 electrons, just put the number of electrons over here. So we'll get 1, 2, 3, 4, 5. You see one unpaired electron. Henceforth, we will find that this compound has only one unpaired electron. So the answer is FeCN6 3 minus. Question number 3. In case of question number 3, guys, what we see that they're asking the collector of electron affinity. I hope we all know that electronegativity order is fluorine, chlorine, bromine, iodine. But when we come for electron affinity, chlorine has a bigger size. Chlorine has vacant 3d orbital. So chlorine having vacant 3d orbital, electron affinity will be, what will electron affinity will be? Chlorine, fluorine, bromine, and iodine. Next. If we go for question number 4, we do find that among the following species, the highest bond order. So if you check all of them, the number of electrons of NO is more in bonding molecular orbital than other ones. NO will show the bond order of 2.5, whereas O2 plus will also show the bond order of 2.5. So both the thing NO and O2 plus are showing 2.5, whereas NO plus will show the bond order of 3. So henceforth, who is having the highest bond order? NO plus. Now question number 5, the one who have intramolecular hydrogen bonding absent. Orthocresol, the first option, if you see, it is nothing but OH, CH3. I think we all know the conditions of hydrogen bond. There should be hydrogen attached to one of the electronegative ions, as well as it should be attached to one of the electronegative atom present in the overall mixture, so which is not present over here. So there can't be any sort of hydrogen bonding, hence here there is no hydrogen bonding. Next one, if we go for question number 6, question number 6 is telling us that in the following species, the central atom is sp3d2 hybridized. If we talk of bromine, BrF5, what we are going to see, it is nothing but looking like this: 1, 2, 3, 4, 5, 6, 7. If you are talking of BrF5, what we are going to get, you are going to get one lone pair. Then these are going to be p orbital. There's 1, 2, 3. This is going to be d orbital. So what we are going to observe, we are going to observe that overall what we are going to observe that it is going to have F. So 5F will be coming like this. And if 5F comes like this, we can see that there are 5 BP, 5 bond pairs plus 1 lone pair, overall 6. So it is nothing but sp3d2. Next, question number 6 done. Question number 7. For question number 7, what we will see, we will find that they are asking us solubility of AgCl in magnesium chloride will be. So they are asking about the Ksp value in this case. Students, if we focus on this, we have to consider that AgCl has Ksp of 8. When we talk of AgCl, that will have the Ksp of Ag plus and Cl minus. Similarly, MgCl2 will have the Ksp of Mg2 plus Cl minus. So it's not being printed over here. No worries, we'll go next line. So what will be for MgCl2? MgCl2, it will be Mg2 plus Cl minus square. I hope all of you do understand now. If we talk of Cl minus concentration, we will get how much? We will get 2 multiplied by 0.2. That will give me 0.4 molar. Now, initially we saw that Ag plus will be 0. And what will be Cl minus? Cl minus will be equal to 0.4. Now, after you are doing, it is going to be plus S. Cl minus is also going to be plus S. Now, at equilibrium, what will be the case? At equilibrium, Ag plus is going to be S and Cl minus is going to be 0.4 plus S. Overall, what we are going to see, the Ksp of the total solution. We know that S is little negligible in this case. As S is negligible, what we can see when Ksp is very small, what we will observe that Ksp will be equals to S into 0.4. That will come, that is 1.8 into 10 to the power minus 10. That is going to give me how much? That is going to give me S into 0.4. What is going to be S? S is going to be nothing but 4.5 into 10 to the power minus 10 molar. I hope all of you understood what we are doing over here. We are finding the fact that Ksp multiplied by S. In case of Cl, it is 0.4 plus S. In case of Ag, it is S. So what will be the Ksp? Ksp should have been Ag plus Cl minus. Now what I did over here, S is negligible. S is negligible. Again, it's not writing. Wait 1 second. What I'm saying over here, S is negligible, and as S is negligible over here, what we can say, Ksp will be directly, Ksp for Cl will be directly equals to 0.4. So henceforth we will get Ksp equals to S multiplied by 0.4. Overall we will get 1.8 into 10 to the minus 10 equals to S into 0.4. Therefore S will be how much? S will be coming 4.5 into 10 to the minus 10 molar. This is what we are going to get S. Next question, if you go, we are finding that question number 7, it is telling us the following process entropy decreases. Now, if you see crystallization, guys, in case of crystallization, it is nothing but liquid to solid. As it is liquid to solid, entropy delta S decreases. Next one, question number 8. In case of question number 8, what we are going to see, the difference between heat of reaction at constant pressure and constant volume of the reaction will be, we will get, first of all, get to find out the delta Ng. Delta Ng is nothing but 8 minus 15, that will be giving me minus 7. Now temperature is nothing but 300.15 Kelvin. Finally, we know the formula delta H minus delta U, that is going to give me del NGRT. This will give me minus 7 into 8.314 into 300 Kelvin, which will give me minus 17.459 kilojoule. It's going to give me minus 17.459 kilojoule. Next one, question number 9. Question number 9, if you see, they are giving the helium is added at the constant pressure in the following reaction at equilibrium. So we have learned that as helium added at constant pressure, the volume will increase. So to balance the equilibrium, the volume has been increasing. Volume increases when helium added. So whenever we add helium, the volume will increase for sure. Whenever the volume increases, to balance the equilibrium, we need more amount to gas to be added on the side to counter it, right? So to counter it, we have to add more thing. Hence, the reactant having more moles will go backwards. If you see the whole reaction, what you will see, they have given carbon monoxide gas plus 3H2 gas in equilibrium with CH4 gas plus H2O gas. So do you see one thing, that is the amount of gas in the reactant side is more rather than the product side. So whenever the thing has been added, what has been added, helium has been added, the reaction or the reactant goes which side? Backwards. It goes backwards. Next, question number 10. In case of question number 10, if you see, they are asking us that in Haber's process for the manufacture of ammonia, the catalyzed used is. Haber's process, when we are doing manufacturing of ammonia, the catalyzed used is Fe. Fe is the catalyst. We know this theoretical question. Now they are asking the next question, ozonolysis, which will be giving me benzaldehyde. Now in this question, if you see, they are telling us that where won't we get benzaldehyde. I hope all of you do remember that whenever we are doing ozonolysis, we do have to cut the bond into two. That is, if there is CPH, PH, CH, CH2, PH, what we have to do, anytime you take ozonolysis, you have to cut this bond into half. As soon as you cut this bond into half, what you are going to get, CPH, C double bonded of PH, and here it will be double bonded OCH2PH. Now, if you see this case is getting benzophenone. Two things are having PH. This is not benzaldehyde. This is also not benzaldehyde. So both of them are not benzaldehyde. Henceforth, what we are going to observe, we are going to observe the fact that none of them will be giving me the product of benzaldehyde. Henceforth, option number 2 will be the correct one. Option B will be the correct one. Question number 12. Incorrect statement they have said. You can see that amylopectin they have said does not contain starch. Is it? Amylopectin does not contain starch. Of course it contains. So henceforth, question number 12, question number 13, question number 13, sorry, question number 13, we can say the amylopectin does not contain starch is the wrong one. So please mark it down that which is the wrong answer. Amylopectin does not contain starch. Question number 13 is the wrong answer. I marked wrongly. This will be question number 13. This will be 12. This will be 10. So I guess I missed one numbering above it. So 7 we did. No, it was 8. So we did 6. Yeah. We did 6. We did 7. Orthoprisol also we did. Definitely. Orthoprisol I did. Yes. Orthoprisol what? 5. So after 5 it was 6. PR F5. Definitely. Then it was 7. 7. Yeah. Then it was 8. Okay. I have marked 2 sevens. That's why. So please change the numbering. I was marking wrong. It was 7 here. It was 8 here. It is 9 here. And it is 10. This one is question number 11. This is question number 12. This is question number 13. Now question number 13 is like aqua solution will freeze at higher temperature. We know I equals to 1 for whom? For glucose. As I equals to 1 for glucose, therefore we can say that delta TF is nothing but TF initial minus TF final. The one who will have the lowest I, that will give me what? Highest TF final. So what will be delta TF? It will be highest. So for glucose, the delta TF will be highest. because we know what is the formula of delta TF. It is nothing but I into KB into M. So less will be the decrease, lesser the I, lesser will be the decrease of delta TF, lesser the I, lesser will be the delta TF decrease. So higher will be the final point. That's it. Next question, we go. The next question they are giving us for galvanic cell, question number 15. They are giving for galvanic cell. This is number 13, is question number 14 at first. Now question number 15. They are asking us about galvanic cell. Now in this question number 15, what we can see is the number of electrons we have to consider. In the case, number of electron is how much? N equals to 2. N equals to 2. If N is equals to 2, anode is what? Anode is zinc giving Zn2 plus 2 electron. What is cathode? Cathode is 2 Ag plus 2 electron giving Ag. This is my cathode. Whenever we are going to find the E cell, it will be nothing but E cathode minus E anode. So it will be 0.80, 0.80 minus of minus 0.76. That will be giving me how much? 1.56 volts. So right answer will be -1. They have asked the delta G value. Fine. So now guys, this is the E naught cell value. What we know? We know that delta G is equals to minus of NF E naught cell. So if I am doing this, I will be having -2 into F into E naught. What is -2? The number of electrons. N, F is the Faraday's constant. So it will be -2 into 1.56 into F. So overall, I'm going to get the value of minus 3.12 F. That is going to be the value for Faraday. Next one, if we go, we are going to find question number 16. That in question number 16, they are asking how many gram of copper metal will be deposited when a solution of copper sulfate is electrolyzed with a current of 9.65 ampere for 10 minutes. So whenever they are talking of 9.6 gram of ampere in 10 minutes, what we have to find, first of all, we need to focus on the fact that they are giving us Q equals to IT. So first of all, what we will do, Q equals to IT, we will write N equals to Q equals to IT means 9.65 ampere multiplied by how much? 9.65 ampere multiplied by 600 seconds, because that they have given. Now, if I do this, I am going to get how much? 5790 coulomb. Number of electrons we are getting, that is Q divided by F. As soon as it is Q divided by F, it is nothing but 5790 divided by 96500. Overall, after the calculation, it is going to come 0.06 mole. Now, Cu deposited, that has been already done. It is number of moles of Cu that we will get as half of number of moles of electron. That is half of number of moles, that is 0.06. Together, how much we are going to get? 0.03 mole. That is going to be half of the number of moles of electron, because the overall charge was coming twice of it. So hence, what will be the mass of Cu? Mass of Cu will be 0.03 into 63.5. That is going to be 1.905 gram. This is going to be a mass of copper deposited according to the Faraday's law. Now, guys, if we go for next, in case of next question, if we focus on question number 17. In case of question number 17, what we are going to see, sorry, not question number 17, we are going to focus on question number 16 first. 16 is done, right? Yeah, 16 is the next. That is question number 17 is the next. So in case of question number 17, absolutely right. 16 we did. So 16, how much we got? 1.9 gram is my amount. And in case of question number 17, a constant of a chemical reaction is this time required for the completion of 20%. So what we have to do over here, in this case, we have to use the formula A equals to A naught minus X. So A equals to A naught minus X equals to 100 minus 20 we have to do. As soon as we are to 100 minus 20, we are going to get 80 units. Therefore, we know that time is equals to 2.303 by K log of A naught by A. That will give us K equals to how much? If you solve this, you are going to get 10 to the minus 2 per second. That's what you are going to get K equals to. Now, finally, if we go for again finding the time, that will be 2.303 by 10 to the power minus 2 log of 100 by 80. As soon as you do this, what you are going to get? You are going to get T equals to 22.33 seconds. We are going to get how much? 22.33 seconds. Question number 18. Now for question number 18, what we see, they are talking of, so in turn, yeah, question number 18, they are talking of some bond energy. So we have to consider the bond energies. First of all, let us find out total bond energy. Total B will be equals to how much? Total B will be equals to half of 436 plus half of 245 plus, okay, this was they have given. Now total bond energy they are considering. So we are considering in case of total bond energy, what the bond energy of hydrogen. And so this is the bond energy given for hydrogen. So this is the bond energy of chlorine. So I'm taking half of because I'm making one HCl. So if I'm making one HCl, how much we are getting from here? We are getting the value of 340.5. If this is the value that we are going to get, what value of HCl they have given? They have given the value of HCl to be 430 kilojoule per mole. That is the value of HCl they have given. Now, students, if we go for this, we can calculate delta H as well. In case of delta H, it will be 340.5 minus of 430, which will be overall coming how much? Minus of 89.5 kilojoule per mole. This will be coming to be how much? Minus of 89.5 kilojoule per mole. So my final answer will be minus of 89.5 kilojoule per mole. Now question number 19, we go. In case of question number 19, we do find that mercury cell, they're asking about mercury cell. I think we all know there is nothing but potassium hydroxide plus zinc oxide together. As soon as we mix them up, we do get the electrolyte of our electrolytes mercury cell. Next, question number 20. Question number 20, they are speaking about the correct order of acidic strength. We all get to know that the strength of correct order of acidic strength, it will be nothing but CF3COH more the minus I more will be the acidic strength. It will be Cl3COH. Then it will be CBr3COH. And finally, what will come? It will be Ci3COH. Question number 21. Question number 21, if we go, question number 21, they're saying that the beta D glucose and alpha D glucose. What are these beta D glucose and alpha D glucose? These beta D glucose and alpha D glucose are anomers of each other. Beta D glucose and alpha D glucose are what? Are anomers of each other. Question number 22. They're asking which of the disaccharide unit consists only glucose unit. So maltose is the one which consists of what unit only? Maltose is the one who only consists glucose units. Question number 23. A mixture of this Hinsberg reagent. So what is Hinsberg reagent? So benzene sulfonyl chloride. What is benzene sulfonyl chloride? If you draw the structure. This structure is called as benzene sulfonyl chloride. This will be acting as my what reagent? Hinsberg reagent. Now question number 24, bromine water reacts with aniline. So if we add Br2 plus aniline, what we are going to get? We are going to get tribromoaniline. So that will be looking like this. And the tribromoaniline will be called to be as what? This will be called as 2,4,6 tribromoaniline, which will be the product of bromine water and aniline. Now next 25. In case of 25, they are asking about catalyst. See, catalyst increases the rate of reaction. It also decreases the time of attaining equilibrium because the reaction is faster and activation is of course decreased. So all the statements are correct. So all correct in this case. 26. Easy. They have just asked the formula. So the formula is nothing but half of pKw. We know by derivation plus pKa minus pKb. Please take a special care that they are considering both of them as weak. So as both of them as weak, this is an easy one to decide. Question number 27, if you go. if you have CH3, CH2, Cl, and you react it with KCl, definitely Cn will get replaced. So it will be CH3, CH2, Cn. And as soon as you give nickel and H2, what I will get CH3, CH2, CH2, NH2. This is going to be my final thing. Now question number 28. Question number 28, what they're saying, if ethane is burnt into excess of oxygen, the oxidation number of carbon changes by. So you are taking ethane and you are burning it in excess of oxygen. As soon as you burn ethane in excess of oxygen, what is going to be the change of oxidation number? What is going to be my change? They're asking about the change. So students, when we talk of ethane, we do find that in case of ethane, it is nothing but 2x plus 6 multiplied by 1, which is going to give me 0, because ethane is having 0 charge. So x will be how much? X will be minus 3. Now, as x is minus 3, students, for CO2, what I will get? For CO2, carbon has an oxidation state of how much? Plus 4. So minus 3 to plus 4, what will be the change? It will be plus 7. Change will be plus 7. So the overall change is plus 7. Now next, they have given E cathode, E anode data. So according to that data of 29, what we can follow? We can follow that in E cathode, E anode data, we can follow that E cell is equals to E cathode minus of E anode. In this case, what we will find? 0.34 minus of minus 2.37. How much it will be coming? It will be coming 2.71 volts. Next, they are talking of conductance. Question number 30. In question number 30, what we see? We see that they are asking about conductance. So according to the conductance part, according to the hybridization part, not conductance, question number 30 is about hybridization. According to the hybridization question, we do see that they are talking about benzene having triply bonded. What is the meaning of benzene having triply bonded? See, carbon is there, right? This carbon is having how many bonds? 1, 2, 3. 3 bonds, and here is H. So benzene, this is benzene. What is benzene? Benzene is this. I hope no, this is called as benzene. Whenever there are 3 bonds present, this is called as benzene. Please see the spelling, and this is benzene. So this is the difference between benzene and benzene. Benzene, the hybridization of triply bonded carbon is sp2. Definitely it's sp2, because we will be considering of this carbon or this carbon. There is no hydrogen. So definitely what will be the hybridization? Sp 1, 2, 3, 4. Now, if you talk of the assertion and reason, they have given that the second pi bond formed by sp2 hybridized orbital. Now you check this thing, this benzene and benzene, what we are discussing over here. This benzene and benzene are totally different from each other according to the haloalkane, haloarine. According to the haloalkane and haloarine. Now, sp2 hybridized orbital is correct. That is of benzene whenever it is triply bonded, because the second pi bond which has been formed is nothing but sp2 hybridized orbital. Henceforth, it is sp2 hybridized, but not sp3. If there would have been any other one which is being taken for consideration, it would have been considered as sp. So please read the question once again very carefully. In benzene, the hybridization of triply bonded carbon is sp2. So the doubly bonded carbons are sp2, but there are two triply bonded carbon. Which can I call it as sp2? No, these two are not sp2. These two will be sp bonded carbon. These two will be what? Sp bonded carbon. So these two are sp and others two are sp2, sp2. So students, I hope you understood. So 4 carbon are sp2 and other 2 carbons are what? Sp hybridized. So as these 4 carbons are sp2 and one and 2 of them are sp hybridized, what will be my correct answer? My correct answer of this question will be the assertion is incorrect, definitely. Now, if assertion is incorrect, then What will be the reason? The reason is saying that the second pi bond is formed by sp2 hybridized orbital. In case of sp2 hybridized orbital, when we discuss sp2 hybrid orbital, this sp2 hybrid orbital, we are getting that the pi bond, the second pi bond. It's not talking of the third pi bond. It's talking of the second pi bond. When we are talking of the second pi bond, it is made by sp hybrid orbital, right? So one is sp hybrid, another one is sp hybrid. So one bond is made by s, another bond is made by p. So can I consider the third bond? No. So if the assertion is only wrong, reason is also going to be wrong. So both assertion reasons are incorrect. Is it clear? So it will be option D. Both assertion and reason is incorrect. Next, going for question number 31. Question number 31, it is saying that halogen is a deactivating group due to minus I effect. Halogen is orthoparadirecting due to plus M effect. Now, halogen is deactivating group due to minus I effect. That is for sure. Halogen is also orthopara-directing due to plus M effect. Is assertion correct? Definitely, assertion is correct. But is the deactivating group minus I effect dependent on the plus M effect? No, absolutely not. So assertion and reason both are correct, but neither the reason is correct explanation of assertion. Is it clear? So question number 30, it is right answer is option. It is option D, and 31 it is option B. 32. 32, they have given the conductivity thing. In case of conductivity, what we will find? We find that lambda m is equals to 1000 into kappa divided by m. Now what we will see? Now normality by molarity, we know it is n factor, isn't it? So what will be molarity? Molarity will be normality by n factor. So if we see this question, what will be lambda m? Lambda m equals to 1000 into 6 into 10 to the power minus 3 divided by n factor. That will be given as what? That will be given as, that is molarity into molarity. So what will be my molarity? Molarity is nothing but 0.001 divided by 2. So this is 0.01 divided by 2. Now if I calculate this, how much I'm going to get? I'm going to get 1200 Siemens centimeter square per mole. I'm going to get 1200 Siemens centimeter square per mole. So my first answer will be the correct one. I hope all of you understood. Molarity is nothing but normality by 2. So normality is 0.1 and mod and n factor is 2. So it is 0.1 by 2. Total all given how much? 1200. So question number 33. In question number 33, what we are observing, they're asking which one above reaction will be the fastest. If G is being replaced by NO2, if I have Cl over here and if I have NO2 over here, I hope you can understand. As soon as I put aqueous KOH, what will happen? The aqueous KOH will immediately replace the Cl very easily. So what I'm going to get? I'm going to get a fast reaction. So due to this case, G will be nothing but NO2. Question number 34. 34 will be, this one is more reactive to nucleophilic substitution reaction than this one. Electron is electron. So absolutely correct. More the electron withdrawing group, better, lesser will be the double bond character, and faster will be the reaction. So it is option A. Both association reasoning are correct. Question number 35. The mixture which show positive deviation from Raoult's law is nothing but ethanol and acetone. We know this very much clearly. Now next one, the mixture which show maximum boiling azeotrope. Maximum boiling azeotrope are always shown by the negative deviation mixture. So among them, who shows the negative deviation? Water and nitric acid shows negative deviation. So answer will be option A. Question number 37. If you see the half-life they have given and they're asking for the calculation. So we know T half is equals to what? T half is equals to 0.693 by K. So it will be giving me 50 equals to 0.693 divided by K. What will be my K? K will be equals to 0.0139 per second. So my K will be 0.0139 per second. 38. Question number 38 is, which of the following is the weakest bond in the base? They have asked. Now guys, weakest among the following of the base, which of the following is the weakest bond state base? They have asked. The one which can't donate the lone pair easily, that will be the weakest bond state base. If I see aniline, the lone pair will be continuous in resonance. Henceforth, aniline will be the weakest of all. Question number 39. If you go for question number 39, you will see that the cyclohexanol, acetic acid, 2,4-nitrophenol, and phenol they have asked. There is a special case which says the exception that 2,4,6 trinitrophenol, 2,4,6 trinitrophenol, NO2. 2,4,6 trinitrophenol. So if I have OH over here, NO2, NO2, and NO2. This is 2,4,6 trinitrophenol. It is a strong acid. It is what? It is a strong acid. It is such a strong acid that this one will dominate over acetic acid. So if I am giving this one as number 3, so what will be my order? It will be 3 greater than 2 greater than 4 greater than 1. This is going to be my order. Next, question number 40. If you see question number 40, they are telling us about Clemmensen reduction. Clemmensen reduction. What will be Clemmensen reduction? Clemmensen reduction is nothing but zinc Hg plus concentrated HCl. Zinc Hg plus concentrated HCl gives me what reaction? Clemmensen reduction. Next, if we look for question number 41, question number 41 is asking which one is the H2SO4 and HNO3. If they react, they give compound B, which is reduced to SN to HCl. Okay, great. If we take benzene, guys, and if we give them H2SO4 and HNO3, we are going to get nitrobenzene. And whenever we give SNHCl, it will change to what? It will change to NH2. Question number 42. Question number 42, they are asking that which is the most basic benzylamine. If you see, guys, benzylamine, it is CH2NH2. Easily the lone pair of nitrogen can be donated. Henceforth, benzylamine the most basic given all of them. Question number 43. Which one is BF3? BF3 is the one who has vacant orbital. If you see boron, it is having the bonding with fluorine. Here is fluorine, fluorine, fluorine. This orbital is vacant, and henceforth BF3 is the one who can accept electron, and that's what BF3 will be acting as what? It will be acting as Lewis acid. Question number 44, if you go, it is the one they are asking that which one is spontaneity is true. Now, student, if you realize when del H is negative and delta S is positive, the reaction, the del G will always be negative. The del G will be always negative. Henceforth, we can find that the reaction will be highly spontaneous. Question number 45, if you see, which is the strongest base among CH3, CH2, CH2, and H2. This one can donate electron very easily, and this can be called to be as the strongest base among all. So overall, this was the paper. I hope all the questions were quite easy. Benzene one, you might face a little difficulty. Other than that, there is no such difficulty in any of the question. So all the best for your NEET. This will be only the level of NEET paper. The NEET paper will be too much justified from the NCERT. All the best. Take care and give the best exam. Thank you, everyone.